So 1.3 starts with domain and range. It jumps right into the first example, but I'm going to talk about a couple things with domain and range before we start example 1. So domain talks about the x values of a function. So domain is the x values where our graph exists. So it's the x values that our graph has. The range is the y values. So range is the y values where our graph exists. When we're talking about domain and range, we write them from the smallest number to the largest. And if it is a closed circle on the graph, we'd write our domain and range, or at that point, with brackets. If it's an open circle, we'd write it with parentheses. And if we're talking about infinity, so whether it's negative infinity or positive infinity, it gets parentheses. So infinity always gets parentheses. So let's take a look at example 1. So domain and range, it kind of helps to visualize when you have a graph for domain. We always look at the x values. So our x-axis goes from left to right. So going from smallest to largest, we want to start at the left side and go to the right. So we want to see what is the smallest x value that our graph has. So what would our smallest x value be? Awesome, -1. So our domain would start at -1. Is this an open circle or closed circle at -1? Closed circle. So we'd put a bracket, -1. Now our graph keeps going. It touches all of these points, all these x values until what value? Where does our graph stop? At what x value? 4. 4 has an open circle. Notice how it's not filled in here. So would 4 get a bracket or parentheses? Parentheses. We're going to do the same thing for our range, but range is y values. So we're going to start at the bottom and go to the top. So what is the smallest y value that our graph has? -5. Awesome. It's a closed circle, so we'd put a bracket, -5. What is the largest y value that our graph has? 4. 4, it's not always going to have that actual closed circle. Sometimes it may just be a continuous graph, but if it's continuous and there is no hole, no open circle, then it gets a bracket. So only when it's an open circle, you'd put a parentheses, or if it's infinity. So domain is where your graph exists on the x value. So our graph is from -1 to 4. The range is the y values that our graph has. So our graph goes in between -5 and 4. Now the second part of this question says find f of -1. So the number in the parentheses tells you what x value to look at. So we want to see what's our y value when x is -1. So we're going to go to where x is -1. This point here, what's our y value? -5. So f of -1 is equal to -5. Let's do the same thing for f of 2. We want to go on our graph, see where our x value is 2. What's our y value when x is 2? 4. So f of 2 is 4. So looking at number 7 at the bottom, we want to use the graph of the function to find the domain and range, then find f of 0. So let's start with the domain. Domain is the x values. So what is the smallest x value that our graph has here? So be careful here. It may look like -2, but our graph is going forever in this direction. My line may be a little bit exaggerated here, but it goes forever in the left direction. So -infinity, perfect. So our graph starts at -infinity. Same idea for the right arrow. This goes forever in the right direction. So what would our largest x value be? Positive infinity. Perfect. Same thing with the range. Range, we're talking about the y values. So what's our smallest y value that our graph has? Negative infinity. We start at the bottom. Our graph is going down to negative infinity. And then our graph stops. What's our largest y value that our graph has? 1. Awesome. Does 1 get a bracket or parentheses? Bracket. There's no open circle at 1, so it's included, so we put a bracket. Last part of this question, we have to find f of 0. So at 0, when x is 0, what is our y value on the graph? 1. So f of 0 is 1. Let's do the same thing for number 9. Let's start with our domain. Domain is x values. So what's our smallest x value that our graph has? -4. Is it an open or closed circle? Closed, so bracket or parentheses? Bracket. What's the largest x value that our graph has? 4. Again, it's a closed circle, so we'd put a bracket. Then for our range, what's the smallest y value that our graph has? 0. Awesome. If we start at the bottom, our graph doesn't start until 0 here. So 0, it's a closed circle, so we'd put a bracket. What's the largest y value that our graph has? 4. Bracket or parentheses? Bracket. And then lastly, let's find f of 0. When x is 0, what's our y value? 4. Next, we're going to talk about finding the domain and range algebraically. So for the next couple examples, it doesn't give us a graph. So we have to kind of either visualize the graph or we got to think about what the question is, what our function is. So for example 2, it gives you the solution below, but don't look at it. We're just looking at f of x is equal to the square root of x minus 4. So we want to find the domain and range. So let's start with the domain. So the domain is our x values. So we got to find what x can and cannot be, or where x exists on this graph. So we have the square root of x minus 4. What can I not have under a square root? A negative. I can't have a negative under a square root. What's the square root of -1? I. Imaginary. We can't put an imaginary number on our graph. We're just dealing with real numbers here. So we want whatever is under our radical to be greater than or equal to 0. So we set whatever's under the square root greater than or equal to 0. So x minus 4 is greater than or equal to 0. Then we solve from here. So we're going to solve for x. We want x all by itself. What should I do? Add 4. So x is greater than or equal to 4. So our domain, we're talking about x values that are greater than or equal to 4. So when we write our domain in interval notation, what's the smallest x value that my graph can have? 4. Awesome. Bracket or parentheses? What do we think? Bracket. If you have greater than or equal to or less than or equal to, you'll have a bracket. If you have just greater than or less than, it'd be parentheses. Because the bracket means that you're including that number. If it was just a parentheses, it'd be everything up to that number. So we have bracket 4. What's the largest x value that our graph can have? Infinity. Awesome. It says x is greater than or equal to 4. We could put 1,000,000, and 1,000,000 is greater than or equal to 4. So infinity would be our largest x value. for our range, we think about y values. So we want to think about like what this is going to be equal to. If I plug in 4 here, we have 4 minus 4, which would be 0, and the square root of 0 is 0. So what do you think our smallest y value could be here? 0. Can I plug in a number and get a negative as my answer after I take the square root of it? No, you can't get anything smaller than 0. So our smallest number for our range is going to be 0. Now let's think. What's the largest number that our y could be? We said I can plug in any number greater than 4 for my domain. So I could plug in 1,000. If I plug in 1,000, can I take the square root of 1,000? Yeah. If I plug in 20 million, can I take the square root of 20 million? Yeah. So it's infinity. And remember, infinity is get parentheses. So our range would be from 0 to infinity. It helps to have an idea of what your graphs look like. So when you have a square root, your graph will look like kind of like a square root, but it looks like this. It's kind of like got that same shape of a square root. So at least knowing what the parent functions of your graph look like can kind of help you with the algebraic part of finding the domain and range. Let's look at 11 down below. So we're finding the domain and range here. It says use a graphing utility, but we're going to kind of graph it in our heads. So for 11, let's think, what does an x squared graph look like? A parabola. Awesome. So parabola has what type of shape? A U shape. So our graph would go up 3 and is a parabola like this. So with our parabola, what do you think our domain is? Is there any number that I couldn't plug into x and square it? There is no number, so it'd be negative infinity to positive infinity. There's no number that I can't plug into x and square it. I could plug in 1,000,000 into x. 1,000,000 squared would be a really large number, but that's fine. We've got no restrictions when we have a quadratic, which is when you have an x squared. So your domain, anytime you have a parabola, your domain is going to be negative infinity to positive infinity. For our range, we're talking about y values. Looking at our graph, what's our smallest y value of our graph? 3. Bracket or parentheses? Bracket. So from 3, what's our largest y value? Infinity. So 3 to infinity. Any questions there? For 13, it's super similar to what we just did in example 2. We're going to do the same thing. What can I not have under a square root? A negative. So I'm going to set whatever's under my square root greater than or equal to 0. So x minus 1 is greater than or equal to 0. We can solve for x, so we want to add 1 to both sides. X is greater than or equal to 1. How would I write that as the domain? What's our smallest x value? 1, awesome. Bracket 1, because it's greater than or equal to. What's our largest x value? Infinity. And then with our range, what's the smallest value that our y could be here? Can I take the square root and get 0? Yeah. Can I take the square root and get a negative number? Anything less than 0? No. So what do you think our smallest number in our range could be? 0. So bracket 0. What's our largest number of our range? Infinity. So again, square root graphs look like this. This one would be shifted a little bit. So it'd kind of look like that. So once you have the graph, it's easier, I think, to find the domain and range. It's a little bit harder algebraically because you kind of have to think about it. You got to think, what does my graph look like, or what values can I or can I not plug in here? For 15, does anybody know what an absolute value graph looks like? A V. Awesome. The last class did not know. It's a V shape. Let's think about our transformations a little bit back from Algebra 2. What does +3 on the inside of an absolute value do to our graph? Which way does it shift it? To the left. Awesome. So we'd shift it to the left 3, and it's a V shape. Something like this. This is a rough estimate of what our graph would look like, but it looks like this. So let's find our domain. What would our domain be? Talking about the x values. Negative infinity to positive infinity. Awesome. There's no number that I could not plug into x. I can take the absolute value of -10 if I wanted to. -10 plus 3 would be -7. It just turns it positive. Absolute values turn your answer positive, but you can plug in whatever number you want here, no restrictions. For our range, what's the smallest y value we could have? 0. Like we said, absolute values make your answer positive, so you'll never end up with your y being a negative number. Or looking at your graph, our graph starts at 0. The y value starts at 0. So we go from 0 to what? Infinity. It goes up forever to infinity. All right, next we're going to do the vertical line test to determine if something's a function or not. Vertical line test is super straightforward. You just want to hold your pencil. It's your perfect example of a vertical line. Hold it over the graph. If your graph touches your pencil in 2 places at once, then it's not a function. So here in our first example, if we hold our pencil over our graph, it touches at 2 places. So it fails the vertical line test. This is not a function. In example B, if we hold our pencil over our graph, it only ever touches in 1 place. So B would be a function. It passes the vertical line test. It is a function. What about for the one on the bottom left? Is it a function or not? Yes, it's a function. If we put our pencil over it, it only ever touches in 1 place. So yes, this is a function. What about for the bottom right? No, it fails the vertical line test because if I put my pencil over it, it touches in 2 places. So this is not a function. Next, we're going to talk about increasing, decreasing, and constant. So when we talk about the intervals of increasing, decreasing, and constant, we write them in interval notation just like we did for domain and range. The one difference for increasing, decreasing, and constant, it is always parentheses. Just because you can't be both increasing and decreasing at the same time. So we don't put brackets, it is always parentheses. Also for increasing, decreasing, and constant, we are only looking at the x values. So if it helps, I would just cross out whatever your y values are, just so you don't even look at them. The numbers on the y-axis do not matter. We're only looking at the x-axis. We're going to use this as an example, even though it kind of gives us the answers. But we kind of talked about this yesterday. You read a graph just like how you read a sentence, going from left to right. So if I start up at the left side, I'm walking downhill here. So I'd be decreasing from what value to what value? What x value am I decreasing in between? -2 to 0. Awesome. So we're decreasing from -2 to 0. And it's always parentheses. Then at 0, we start walking in a straight line. We're not increasing, we're not decreasing, we are constant. So from 0 to what number am I constant? 0 to 2. Awesome. Then we start going uphill again. So we're increasing from 2 to what? To 4. So we're increasing in between 2 and 4. So we only look at the x values, and it is always parentheses. So with the first example, A, I'm going to say that these are arrows. We'll make them arrows at the left and the right. So for increasing, decreasing, and constant, we're ignoring the y-axis. We're just looking at the x values. So we start at the left side of our graph. Would I be walking uphill or downhill? Uphill. We're going to pretend that this is just always going uphill. So I'm increasing. Increasing from what to what? Negative infinity. This graph isn't super clear, but we're just going to say we're increasing the whole way. So negative infinity to positive infinity. So because the arrow is going forever in the left direction, the left over here is negative infinity. The right side over here is positive infinity. So our graph is still increasing as we go to the right. Let's do the same thing with B. So I'm going to pretend that these are closed circles here. So we start on the left side of our graph. Would I be walking uphill or downhill? Uphill. I'm walking uphill starting. I'm also going to add tick marks here so we can kind of see values. I'm walking uphill from where to where? From where? Where do we start? -2 to what? -1. Awesome. We're increasing from here to here. So from here to here, this part of our graph. So that would be -2 to -1. Then we start walking downhill. So we're decreasing from where to where? -1 to +1. Awesome. Then we start going back uphill again. So we're walking uphill from where to where? +1 to about 2. So we're increasing again. So since there's another interval of increasing, when you have more than one interval, you use the little U symbol. I think WebAssign will make you put a U in it. The U just stands for and. So we're saying we're increasing from -2 to 1 and from 1 to 2. So if you have more than one interval, you'd want to use the U. Let's do C. For C, I'm going to make the first one a closed circle and the second one an arrow. Now I'm just drawing whether it's a closed circle or an arrow just because it doesn't have it on these graphs, but on a tester quiz you won't have to put that. It'll be there. Same with WebAssign. The graphs will be a little bit more clear. So for C, we start from the left. I'm going to cross off the y-axis so we don't get confused. And I'm just going to put some tick marks here so we can make it a little bit more clear. So we start by walking uphill or downhill? Uphill. So we're increasing from where to where? Awesome. -2 to 0. Then what happens at 0? We're constant. We're walking in a straight line. So from 0 to what? Perfect. From 0 to 2, we're constant. Then at 2, what happens? We're decreasing. So we're decreasing from 2 to what? So we have an arrow, so that just means we keep decreasing to infinity. A lot of people, especially when the arrow's pointing down, thinks that we're decreasing to negative infinity. That's a common mistake that people will make. But remember, we're going in the right direction. So right, the numbers get bigger. You've got infinity over here at the right, negative infinity at the left. Relative minimum and maximum values. So relative maximum, you can kind of think about it as like peaks and valleys. So the highest point when you're increasing and then decreasing, so the peak of a mountain would be relative maximum. The valleys, so when you're decreasing and then increasing, would be your relative minimum. So relative maximum, it's not just the highest point of the graph, it's where you have that peak of the mountain. It's like tippy top of a mountain. Same with the relative minimum. It's not the absolute lowest point of the graph, it's just where you have the valley. So in our last example, at this point here, so if you look up at the board, what would this be? Relative minimum. So it's not the lowest point of our graph, it's just where we have that valley. What about the point up here? That would be our relative maximum. So again, it's not the absolute highest point of our graph. We've got higher values over here, but it's where you go from increasing to then decreasing, so it's like the top of the mountain. So this graph's super hard to tell like where the point is, but whatever that point would be, this graph, the numbers are too small, but it would be whatever the point is. So you'd say a relative maximum at this point. And the second graph is the same picture.